Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about fin stabilizer placement on the ship and how that can affect overall performance and comfort. You might have some counterintuitive findings in how this might affect performance. So let's take a look at the 50-meter generic yacht. We're going to look at two examples here and explore the ship performance to use this as kind of an illustrative example. So I've got 3-meter square fins set up on the left-hand side here. I've got them set up at station 10, basically, where the maximum beam is. Now, at first glance, you might think that this is a great place to put them because it's got a maximum lever arm to apply forces and control the roll motion the most, and certainly it will do that. However, there's more to it than that, and there may be other good reasons to have fins at another location, which we'll see in a moment. In the other case here, we have them at station 5, so they're further forward, not as far out to the side, but we're going to explore from a hydrodynamic perspective how this might overall affect ship motion performance and comfort. So, of course, this is the scope that's limited to what we're talking about. There's many other reasons and advantages and disadvantages to placing fins at other locations. Where's the machinery going to go, and other considerations. We're just focusing on the ship motion performance aspects of things. So first thing we want to do is just look and see what the roll RAO looks like. So in the ProteusDS Ship Motion 3D toolset, we're going to go to CKeep Regular, and now, I confused myself because I opened two copies of the same project in the same folder. Make sure you have the file name prefix that's different. Otherwise, they'll be overwriting each other's files. Probably a better idea to have separate folders for this. But anyway, here we go. This is station 10, so that's the midships case. Let's run the roll RAO here. And then similarly here for the station 5 case. So these are the fins that are a little bit further forward. And we'll plot motion RAO, look at the 12 knots case and beam condition. So we have a roll RAO of 1.9. Go OK. And look at the 12 knots case and the roll beam loading case here, and we have 1.2. So this is what we expected. We expected to see a lower roll motion when we have the fins at a maximum beam, and that makes sense. It's intuitive. There's that greater lever arm. We're getting a lower maximum roll motion, 1.3 instead of 1.9. In other videos we talked about comparing this to the bare hull. I think the bare hull roll RAO is around 11. So either case, they're both doing very well, but you do get better performance when you have them in a pure beam loading case. The fins only at the midships at maximum beam. But there's more to ship motion than only pure beam loading, and that's when you might get some advantages to having the fins placed further forward. So rather than looking at individual cases in a specific sea state, I want to pivot over to the ship motion toolbox and perform a comfort analysis on this. So this is using seakeeping calculations across a wide range of sea states. It's using motions and accelerations calculated at 5 different areas on the ship: the owner's cabin, dining area, wheelhouse, etc. And we want to see what the overall motions and operability comes out of and make a comparison to that. So I've pre-computed the results here. They really do only take a second to calculate, but here we go. So we have the fin. Here's the results with the fins at station 10, midships with a maximum beam. And then here we have the fins a little bit further forward at station 5. And we see that there's a greater comfort rating, a higher operability value when the fins are placed further forward, 59%, and whereas it's only 54%. So that's kind of strange. Why might that be? Well, first of all, let's look closer at some of the results here, the individual results at 0 speed condition. So if we look at, first of all, you see a pretty big difference, 66% for the fins at midships at maximum beam, and then almost 79% for fins a little bit further forward. Well, I wonder what the difference is here. So now another thing to note, these fins we don't have the hydrodynamics of zero speed operation incorporated at zero speed. So this is a passive effect from the damping of those fins. So if we look at the incidence of motion sickness, you see an interesting difference in the results here, where you've got a lot lower. The threshold is 10%, and you can see a couple of sea states where this design with the fins further forward is exceeding it, and more sea states where the motion sickness is exceeding it. Now this kind of makes sense because motion sickness is often, not always, but it's often driven by pitch motions. And of course, having the fins further forward helps create a lot more resistance to that pitch motion, slows things down, and reduces the incidence of motion sickness. Now, of course, when we're looking at all the different cases that it's considering, there's many different periods of sea state. Remember that these are all evaluated in a bow quartering condition. So it's not pure roll motion. There's a little bit of pitch, there's a little bit of heave, a little bit of roll, all factors into this. It's not a pure roll motion. Okay, now the other thing that we want to do is look at 12 knots here, and when we look at the incidence of motion sickness, we see they're largely kind of the same, so that's not where the fins are helping the most. But if we look at the effective gravity angle, we can kind of gauge what's going on here a little bit. Largely, they seem to be pretty similar. Effective gravity angle is going to be affected by the accelerations primarily from roll, but there's other effects happening too. Actually, you see the case where the fins are a little bit further forward. It's a tiny bit lower, 39 versus 42. So the fins are doing a better job here. This one case, the limit is 2 degrees, so it's just going over that limit with the fins a little bit further forward, but they're pretty close. In any case, the overall comfort rating factors in everything, all the different cases at zero speed, at 12 knots, and unequivocally, you can look at the overall rating and see that it's higher comfort rating when the fins are placed a little bit further forward. So that's what I wanted to highlight. Sometimes these things can be a little bit counterintuitive. You think fins would help at maximum beam case. Maybe it would be like that for even with the comfort rating in considering other cases, depending on the specifics of the yacht that you're looking at. But that's what's great about ProteusDS. You can look at a specific case, look at the specific yacht that you have or ship or whatever with fin stabilizers and go through this process. And you have more than one way to see and gauge how the performance improves. All right, that's all I want to talk about for today. Thanks for watching.